the hidden engine of metabolism. How brown fat builds its own support system, while much of our focus regarding weight management centers on what we eat. Recent scientific breakthroughs suggest that how our bodies burn energy is just as critical. New research has pulled back the curtain on brown fat, revealing that its ability to regulate metabolism depends not just on the cells themselves, but on a sophisticated biological infrastructure of blood vessels and nerves. The difference between white and brown fat. To understand this discovery, it is essential to distinguish between the two primary types of adipose tissue in the human body. White fat, the more common type that accumulates around the belly and hips, primarily serving as energy storage. Brown fat, brown adipose tissue, a metabolically active tissue packed with mitochondria, the engines of our cells. Unlike white fat, brown fat utilizes a protein called UCP1 to perform thermogenesis, a process where cells burn calories specifically to generate heat. This makes brown fat a natural ally in weight regulation and metabolic health. The discovery, the SLT3 protein system having brown fat, is not enough to ensure a high metabolism. The tissue must be plugged in to the body's systems to function. A study published in Nature Communications has identified the mechanism that builds this connection. By analyzing tissue samples from over 1,500 individuals, researchers discovered that brown fat cells secrete a protein called SLT3. Rather than acting as a single unit, SLT3 splits into two specialized fragments that act as architects for the tissue's infrastructure. SLT3N, the fuel line. This fragment triggers the growth of new blood vessels, ensuring the brown fat receives the oxygen and nutrients required to burn calories. SLT3C, the control switch. This fragment promotes nerve growth, building the neural networks that signal the brown fat to activate and begin generating heat. Without both fragments, the system fails. Without blood vessels, the tissue lacks fuel. Without nerves, it lacks the command to turn on. Why this matters for obesity research. This finding provides a crucial piece of the metabolic puzzle. The study noted that individuals with obesity often possess less of this vascular and neural infrastructure in their brown fat, which may explain why their metabolic rate is lower even if the fat cells are present. Historically, obesity treatments have focused heavily on the input side of the equation, reducing calorie intake through appetite suppression or limiting absorption. This research shifts the focus toward the output side, enhancing the body's innate ability to burn energy. If scientists can develop therapies to enhance SLT3 activity, we may see a new generation of treatments that make the body more efficient at burning calories by optimizing its natural metabolic machinery. Bridging the gap. Current versus future strategies. While medical breakthroughs involving SLT3 are likely years away from clinical application, there are existing lifestyle habits that support current brown fat activity. However, it is important to note the distinction between activating existing fat and building new infrastructure. Ways to support existing brown fat. Cold exposure. Brief periods in cooler environments or cold showers may trigger activation. Physical activity. Regular exercise is linked to improved brown fat function and may help convert some white fat into metabolically active forms. Dietary triggers. Compounds like capsaicin, found in chili peppers, and those in green tea may assist in activation. The caveat: while these methods can help turn on the engine, they do not necessarily build the complex network of blood vessels and nerves that the SLT3 system provides. Conclusion: this research marks a significant shift in metabolic science, moving from looking at fat as a mere storage unit to viewing it as a complex network system. By uncovering how brown fat builds its own power grid, scientists have opened a promising new door for treating obesity through enhanced energy expenditure.